Usually, when you think about fundamental physics, you expect absolute binary precision. You imagine a massive machine like the Large Hadron Collider just spinning particles at the speed of light.
Right, highly clinical.
Exactly. You smash two protons together, the detector lights up with this jagged white line, and a physicist points to a screen and says, there it is, a quark.
Hmm.
It feels so, well, broken or not broken,
Hmm.
particle or not a particle.
I mean, we deeply crave that kind of categorization. We really want the universe to be made of visible, distinct little boxes that we can just, sort and label.
Right. But suddenly, you step into the world of theoretical physics, specifically this cutting edge of alternative particle models we have in our stack of sources today, and that pristine X-ray machine just breaks down
Oh,
completely.
that shatters.
Yeah, it shatters. You, the listener, are suddenly looking at a theoretical landscape that is murky, confusing, and totally counterintuitive. So today, our mission for this deep dive is to navigate that diagnostic mud.
And it is thick mud.
Very thick. We are essentially ripping up the textbook standard model of physics and examining some truly radical theories that want to replace the 80-plus distinct particles in your body with one single continuous vibrating note.
It's a massive paradigm shift. I mean, we are looking at a suite of concepts today, primarily particle theory A, along with its sibling frameworks, the unified resonance model and the fabric of space model.
Right.
And to understand what they are trying to do, you really have to completely discard your current mental image of the universe.
Okay, let's set up a new mental image then. Imagine you are staring at a massive, ultra-high definition digital billboard.
Okay, I'm picturing it.
If you follow the mainstream standard model of physics, you believe that billboard is made of millions of distinct individual physical bulbs. You can point to a red bulb and call it a quark. You can point to a blue bulb and call it an electron. They are separate physical objects wired together.
Right. But these alternative theories propose something entirely different. They suggest that there are no individual bulbs at all.
Wait, no bulbs.
None. Instead, the universe is just one single continuous sheet of glass, a fluid medium, essentially. What you perceive as a, red bulb or a blue bulb is simply a localized spot where that continuous sheet of glass happens to be vibrating at a specific frequency.
Just a localized wave. Nothing solid at all. Wow, so we're going to unpack exactly how these theories attempt to explain the fundamental forces of the universe without using solid particles.
We really need to get into the weeds on this.
Oh, we will. We'll explore the exact specific math that makes this possible, how it compares to the physics taught in universities right now, and crucially, why mainstream science is fighting back so fiercely against it.
What's truly fascinating here is that while these theories might sound like rogue internet speculation or pure science fiction, they are actually rooted in a century-old quest.
Really? A century.
Oh yeah, this is the direct continuation of a journey started by Albert Einstein himself, a quest to find a single unified geometry of the universe.
Okay, well, let's start there. To understand why any physicist would want to throw away a perfectly good model of individual particles and replace it with a single vibrating fluid, we have to look at the historical frustration of physics.
Mm.
What exactly was Einstein trying to solve?
It's all about unification. I mean, the history of physics is essentially the history of realizing that two totally different things are actually just different expressions of the exact same phenomenon.
Like electricity and magnetism.
Exactly. James Clerk Maxwell did it first in the 19th century. People thought electricity was one thing and magnets are another, totally separate thing. Maxwell wrote down a set of equations and proved that they are two sides of the identical coin. Electromagnetism.
And then Einstein steps in and tries to do the exact same thing for gravity.
Yes. In 1915, he released general relativity, which completely geometrized gravity. Before that, Newton basically told us gravity was a magical, invisible tether pulling objects together across empty space.
And Einstein said no.
Right. He said space itself is a fabric.
It's a classic analogy, but let's upgrade it for the listener. It's not just a bowling ball on a trampoline. It's like you're swimming through a three-dimensional grid of water, and massive objects literally warp the grid lines around them.
That's exactly it.
You aren't being pulled by the Earth. You're just slipping down the geometric slope that the Earth has carved into space.
That's a great way to visualize it. But here is the critical part of Einstein's life that most textbooks just gloss over.
Okay, what is it?
He wasn't satisfied with just geometrizing gravity. He spent the entire latter half of his life trying to merge electromagnetism and gravity into one single, unified hyperfield.
A hyperfield. That sounds like sci-fi.
It does. But he was deeply uncomfortable with the idea that space was a curved geometric fabric, but that particles like electrons were just separate, hard little billiard balls sitting inside that fabric.
Wait, so what did he want particles to be, if they are billiard balls?
He wanted them to be solitons in the geometry itself.
Okay, hold on. Solitons. If we're going to throw out the physics textbook, we need to make sure we don't lose the listener on page 1. What exactly is a soliton?
Well, it's a very specific kind of wave.
Are we talking about a wave that just holds its shape, like, I don't know, tsunami traveling across the ocean without dispersing?
That is a perfect physical example. Actually, in the 1800s, an engineer named John Scott Russell was watching a boat being pulled through a canal. The boat suddenly stopped, but a single massive wave of water rolled off the bow and kept traveling on the canal for miles.
Without losing its shape.
Without losing its shape or flattening out. It was a wave, but it acted like an independent, solid object. That is a soliton.
So Einstein wanted an electron to be like that canal wave. Not a hard pebble dropped in the water, but a self-sustaining knot or a fold made out of the water itself.
Precisely. He believed that if you could find the right mathematics, you would see that matter is just highly condensed space.
But mainstream physics took a completely different detour, didn't it? We didn't follow Einstein's geometric dream all the way down.
No, we didn't. The mainstream went with quantum field theory, or QFT.
Right.
QFT elevated abstract fields to the status of the most fundamental objects in nature. It treats particles as localized excitations in these underlying invisible fields. It works incredibly well mathematically, but
it relies on statistical probabilities rather than mechanical physical geometry.
exactly. It's math, not physical folding.
But there was a massive turning point right around 1925 that these alternative theories we're looking at rely on. It involves a French physicist, right? Louis de Broglie.
Yes, Louis de Broglie. He proposed something called the clock hypothesis. He mathematically proved that every material particle carries an internal vibrating frequency, like a clock wave.
Okay, so every particle is a rhythm.
Right. Now, mainstream quantum mechanics took this idea and turned it into the wave-particle duality we know today, but they treated the wave as a wave of probability.
Meaning the wave just tells you the mathematical likelihood of finding a solid particle in a certain spot. It isn't a physical wave.
Exactly, and this is where the split happens, because the alternative resonance models we are looking at today take de Broglie literally, not as a statistical probability, but as physical reality.
They argue that a particle is not a solid object surrounded by a probability wave.
No, they argue that the particle is a physical standing wave of curved, quote-unquote, proper time.
So instead of a particle being a tiny billiard ball, it's more like a trapped echo. Imagine an echo in a canyon that bounces back and forth so perfectly, so symmetrically, that the sound wave basically freezes into place and feels solid to the touch.
A trapped echo vibrating in a closed loop. That's a great analogy. If the echo is stable and closed, we experience it as solid matter. If the loop is open and traveling, we experience it as energy, like light.
Which brings us directly to the first specific framework we are unpacking today. Particle theory A.
Right, the A theory.
Building on this idea of waves and echoes, particle theory A proposes a single fundamental substance, called particle A, which exists as a continuous fluid called field A.
A single fluid.
Yeah. In this theory, there are no quarks. There are no distinct electrons. Everything, mass, energy, forces, is just a manifestation of the density and the vibration of this one singular field.
The standard model says, here is a quark field, here is an electron field, here is a photon field. Particle theory A says, there is only field A.
One field to rule them all.
Exactly. When field A gets densely packed and vibrates in a specific geometry, you get the illusion of an electron. When it vibrates differently, you get a photon.
The word illusion is key there. I mean, under this theory, mass doesn't actually exist as an independent property of the universe. I find that totally mind-bending. Mass is just the density of particle A clumping together.
Think of it like a massive crowd of people moving into a town square.
Right.
The crowd isn't a brand new, distinct physical object that magically appeared out of nowhere. It is simply a region of high human density. Mass is the exact same thing. It is just a region where field A has clumped together so tightly that it resists being moved.
And if mass is just a localized density of this field, it completely redefines how we understand gravity. Because under theory A, gravity isn't a pulling force at all.
Not in the slightest.
Okay, I'm stuck here.
Yeah.
I'm playing the skeptic for a second. If gravity isn't a pull between two objects, how does that explain why an apple falls to the earth and exactly 9.8 meters per second squared. Does the actual physical mechanism hold up to Newton?
It does, but through a completely inverted mechanism.
Inverted how?
Think about how a foam mattress behaves when you press your hand into it. The foam compresses, right? It gets denser, right under your hand.
Yeah.
But the foam wants to snap back. It wants to equalize the pressure. In particle theory A, gravity is simply the restoring force of field A.
The restoring force. So the universe is trying to iron itself out.
Yes. When field A gets heavily clumped and dense, which is what we call a massive object like the Earth, the surrounding field naturally tries to balance itself out. It tries to equalize the pressure gradient.
Oh, I see.
That slope, from an area of high density to low density, creates a literal pushing effect. The apple isn't being pulled by the Earth. The apple is being pushed downward by the universe, trying to equalize the density of field A around the Earth. We just misinterpret that push as a gravitational pull.
That is a wild reframing. Does the math actually support a pushing gradient instead of a pulling force? Because physics runs on math, not just foam mattress analogies.
It absolutely does, and the sources provide specific equations. In classical physics, Newton's law of gravity relies on the gravitational constant, a fixed number denoted as g.
Right, big G.
But particle theory A says g isn't completely constant. They introduce a modified gravity equation. It goes like this. K subscript A as a function of rho A equals g times the quantity 1 plus eta times rho A over rho 0.
Okay, let's translate that algebra into English for the listener,
Yeah.
because that was a lot of variables.
Fair enough. Essentially, it means the gravitational constant becomes a dynamic variable called Ka. It fluctuates based on the local density of field A, which is represented by that rho A term.
So it changes depending on where you are.
Exactly. If you are floating in a region of space where field A is incredibly thick and dense, gravity actually behaves slightly differently than it does in totally empty, low-density space. The quote-unquote constant adapts to the medium.
And they apply this exact same logic to the speed of light, don't they? The equation they present is v equals c times the square root of 1 minus rho A over rho 0.
Let's break that down, too.
Right, so c is the absolute speed of light in a vacuum, about 300,000 kilometers per second.
Yeah.
But as the density of field A, that rho A number, goes up, the mathematical value under that square root becomes smaller than 1.
Right.
And when you multiply the speed of light by a number smaller than 1, it drops, meaning the speed of light actually slows down when it hits a dense pocket of field A.
Precisely. And if you are wondering why you should care about this slight mathematical tweak to the speed of light, it's because this specific mechanism offers a brilliant, almost suspiciously simple solution to the biggest headache in modern cosmology.
Dark matter.
Dark matter.
The invisible ghost of the universe. I mean, we look up at galaxies spinning, and they are spinning so fast that they should literally tear themselves apart and fly off into the void.
Yeah.
There isn't enough visible mass, stars, planets, dust, to create the gravity needed to hold them together. So mainstream physics says there must be some invisible dark matter acting as cosmic glue.
Right. Mainstream physics assumes dark matter is an undiscovered, weakly interacting massive particle, a WIMP.
A WIMP, yeah.
They assume it's a new bulb on the digital screen that just happens to be invisible. But we have been building billion-dollar detectors for decades looking for these particles, and we have found absolutely nothing.
Enter particle theory A. It says we haven't found a dark matter particle because there is no particle to find. Dark matter is simply a primordial pocket where field A is extraordinarily dense.
Exactly. It's just a thick patch of the fluid left over from the chaos of the Big Bang. And because it's a dense patch of field A, it creates a steep density gradient. And as we just established, a density gradient in field A is gravity.
So you get a region of space that exerts a massive gravitational push, holding galaxies together and bending light around it, but there's no actual solid matter there to reflect light. It's just a thick patch of space. It's gravity without mass.
It's beautifully elegant compared to inventing invisible, ghost-like particles.
It is elegant, but it brings me to a major roadblock. Theory A gives us this general vibrating fluid, but how do we get the specific, rigid, identical particles we actually measure in labs? Every single electron in the universe has the exact same mass. If there are just clumps of fluid, why are they all identical? How does a generic wave turn into a precise electron?
That mechanical void is exactly why Theory A needs its mathematical sibling, the Unified Resonance Model, or URM.
Ah, URM.
Yes. If theory A is the conceptual idea of the fluid, URM is the hyperspecific mathematical engine that explains how the fluid folds into exact shapes.
URM introduces what I like to call the formula of reality. W equals A times R. Energy equals the geometric amplitude of the wave multiplied by its rotational rhythm.
This is a geometric evolution of Max Planck's famous quantum equation, E equals h nu. For a free-flying photon, a particle of light, the wave just propagates linearly. It shoots forward. The rotational rhythm, R, is just its frequency. It travels through time without resistance.
But when two harmonically compatible waves crash into each other constructively, the URM says something magical happens. They don't just pass through each other.
No, they don't.
They fold into a closed loop, they trap their own rotational rhythm, they curve proper time into a localized ring.
And when a wave's rhythm persists and spins in a circle against the surrounding curvature of space, that localized trapped energy manifests as what we call mass.
Okay, here is where we need to dive deep, because URM claims it can actually calculate the exact mass of fundamental particles from scratch, using only geometry.
Which is something the Standard Model cannot do.
Right. The Standard Model relies on the Higgs boson to grant mass to particles. But the Higgs mechanism doesn't actually predict what those masses should be. Physicists just have to measure the mass of an electron in a lab and then manually plug that number into the Standard Model equations as a free parameter.
It's essentially reverse engineering.
Yeah, totally. But URM says, no, we can derive the mass of an electron geometrically using a curvature amplifier. What exactly is this amplifier?
Well, URM rejects the infinite abstract mathematics of quantum field theory. It says physical space is finite and self-limiting. To model how a wave folds into a stable loop, URM uses the golden spiral.
Like the Fibonacci sequence.
Yes, but importantly not the infinite mathematical golden ratio you might have learned in geometry class.
Oh, really? It uses a finite version, denoted as phi.
Exactly. Physical reality can't go on to infinity. It emerges from real Fibonacci recursion. If you take the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, and divide a number by its predecessor, it approaches the golden ratio. URM postulates that spatial geometry settles after about 7 or 8 iterations.
So like 21 divided by 13.
Right. It comes out to a finite ratio of approximately 1.615.
Okay, so we have a physical golden ratio of 1.615. How does that turn into an amplifier?
Imagine a wave curving through our specific universe. We live in a 4-dimensional spacetime. 3 spatial dimensions, up, down, left, right, forward, back, and 1 dimension of time.
Got it.
Each orthogonal axis of curvature contributes to the overall resonance. When you calculate the spatial wave amplitude, the temporal compression, and the angular spiral closure across all 4 dimensions, the formula they derive is 2 pi times phi to the 4th power.
2 pi, representing a full geometric circle, multiplied by the golden ratio to the power of our 4 dimensions.
Right, and when you plug in 1.615 for phi, the calculation 2 pi times 1.615 to the 4th gives you a universal curvature amplification factor. They call it eta, and it calculates out to approximately 42.85.
Eta equals 42.85. This is the secret multiplier of the universe.
That is the claim. Now, to use a multiplier, you need a base number to multiply. URM states that all free photons carry a base invariant energy quantum.
Think of it as the minimum kinetic energy required to force a straight flying photon to bend into a closed geometric loop.
Exactly. They call this base energy alpha, and it's equal to about 5.96 kilo-electron volts, or keV.
So we have a raw material, a base energy of 5.96 keV, and we have our geometric folding machine, the amplifier of 42.85. Let's build an electron.
Let's do it. An electron is the simplest particle. It is defined as resonance state n equals 1. It's a single stable loop formed by 2 interacting photon harmonics.
Because it takes 2 waves to make a stable standing wave.
Right. So the math to find the rest mass energy of an electron is simply 2 times alpha times eta.
So 2 times the base energy of 5.96 keV times the single amplifier of 42.85. If you run those numbers, it comes out to 510.7 keV, or roughly 0.511 MeV.
Which is astonishing.
It is, because 0.511 MeV is the exact experimentally verified mass of an electron.
It derives the mass of an electron entirely from geometric principles, without ever needing a Higgs field or arbitrary mathematical couplings.
That feels like finding a cheat code to the universe. But it goes further. Let's build a proton. A proton is much heavier than an electron, and it's a 3D object.
Right, an electron acts like a single 2D loop. A proton is a highly stable three-dimensional vortex. It requires three orthogonal loops of resonance on the x, y, and z axes. So its resonance state is n equals 3.
And here's where the math gets visually intuitive, because the wave is locking itself down across 3 spatial dimensions. The amplification factor compounds. It multiplies against itself for every spatial dimension it folds into. So you don't just use eta, you use eta cubed.
Exactly. Eta cubed is 42.85 times 42.85 times 42.85, which comes out to roughly 78,693.
So the proton mass equation is 2 times the base energy of 5.96 keV times the 3D amplifier of 78,693. That equals approximately 938 MeV.
And once again, 938 MeV is the known verified mass of the proton.
It's a profound mathematical coincidence, if nothing else. It suggests that particles aren't different ingredients, they're just different dimensional folding patterns of the exact same energy.
It really does.
I love comparing this to 3D origami. A free-flying photon is like a flat piece of paper. It has energy, but no mass. It doesn't weigh anything.
Right.
If you fold it once perfectly, creating an electron, it suddenly takes up localized space. It resists being moved. It has weight. If you fold it 3 times perfectly on 3 intersecting axes, you get a proton. It becomes a tight, incredibly stable, complex 3D knot.
And the constants, the eta and the alpha, are simply the precise geometric angles and lengths required to make those origami folds hold their shape without springing open.
That origami analogy holds up remarkably well to URM's underlying geometry.
It really does.
So URM gives us this beautiful, predictive geometric math. But math isn't mechanics. Math tells you what happens and the proportions involved, but it doesn't give you the physical texture. It doesn't tell you how the gears turn.
No, it doesn't.
And that mechanical void is exactly why some physicists abandon geometry altogether and look at the universe through a completely different lens. The fabric of space model, or FOS.
Right, FOS.
Let's look at FOS. But to understand it, we need to explicitly state what FOS is fighting against. What is the mainstream standard model's view of how a proton is built?
Well, the mainstream view is quantum chromodynamics. The standard model views the universe as being permeated by more than 80 distinct invisible quantum fields.
80 fields.
Yeah, there is the electromagnetic field, 8 different gluon fields, 12 weak interaction fields, 24 fermion fields for the different quarks and leptons, the Higgs field, and more.
Just stacked on top of each other in empty space.
Yes. And in this view, a proton is not a single folded wave. It is a composite object. It is a literal bag filled with 3 point-like particles called quarks, specifically 2 up quarks and 1 down quark.
Those quarks are held together by a chaotic swarm of virtual particles called gluons, which mediate the strong nuclear force.
Right.
The critique of this from the FOS community is absolutely brutal. They compare the standard model to the epicycles of Ptolemaic astronomy.
That's a deep historical cut.
It really is. Back in the ancient world, astronomers believed the Earth was the center of the solar system. But when they looked at the sky, planets like Mars would sometimes appear to stop and move backward retrograde motion.
Right. Which ruined their models.
Exactly. Instead of throwing out their Earth-centric model, they just added invisible mathematical loop-de-loops, called epicycles, to the planet's orbits to make the math work out.
Ah.
The FOS argument is that the standard model is doing the exact same thing today. Every time their math breaks down in a particle collider, they just invent a brand new invisible field or a virtual particle to patch the hole.
It is a harsh critique, but it stems from a deep desire for mechanical, physical simplicity. The fabric of space model offers a completely different mechanical explanation for reality.
How so?
It treats the universe not as an overlapping grid of 80 abstract fields, but as a highly compressible, elastic, mechanical medium. They sometimes call it ether pressure.
So, if the universe is a fluid-like pressure medium, what is a proton in FOS if it isn't a bag of 3 quarks?
In FOS, a proton is simply a compacted pressure node. It's a standing wave compression structure whose surface is rapidly pulsating and rotating.
But wait. Mainstream physicists shoot high-energy electrons at protons all the time in colliders. And when the electron bounces off the proton, the detectors clearly show it bouncing off 3 distinct hard centers inside the proton. That's why we believe in quarks. How does FOS explain those three hard centers?
Well, FOS argues that you aren't looking at three permanent internal marbles. If the proton is a rotating, pulsating sphere of pressure, its surface will have natural resonant frequencies.
They're like a bell.
Think more like a water droplet suspended in the air on the space station. If you vibrate it with sound, the surface of the water will form distinct transient density lobes, ripples that look like geometric bumps.
So when the electron bounces off the proton, it's just hitting a temporary high-density ripple on the surface of the wave structure.
Exactly. FOS argues that those three density lobes are transient surface fluctuations. Mainstream physics mathematically interpreted those bumps as three internal permanent particles and named them quarks. FOS says that's a category error. They aren't real permanent objects.
And FOS points to a very specific, undisputed experimental fact to back this up: annihilation experiments.
Yes. This is perhaps the most compelling mechanical argument they have. When you collide a proton and an antiproton in a collider, they completely annihilate each other.
Boom.
Boom. Now, logic dictates that if a proton is a bag containing three indestructible quarks, you would expect those individual quarks to fly out of the explosion, right? Like smashing a piñata and seeing the candy spill out.
Exactly. We smash them, we should see the pieces.
But we never do. Quarks have never been observed in isolation, ever. The decay chain of a destroyed proton always uniformly ends in pions, which quickly decay into muons and finally into electrons, positrons, and gamma rays. Leptons and photons. That's it.
So FOS looks at that and says, if quarks were real, physical components, we would see them in the debris. Because we don't. FOS claims the proton is just a highly complex, stable wave structure. And when you destroy the stability of that wave, it naturally unravels and collapses back into simpler, lower energy waves, electrons and light. No quarks required.
That's the argument.
Okay, to clarify the landscape for the listener, we have two alternative theories here, URM and FOS, that both aggressively reject the standard model's 80 fields and its quarks. But how are FOS and URM different from each other?
That's a crucial distinction to make. They share a disdain for the complexity of the standard model, but their underlying ontologies, their view of what reality is actually made of, are different. FOS is highly mechanical.
Right.
It relies on fluid-like pressure, physical compressibility, and longitudinal wave compression in a literal physical medium. It's fluid dynamics.
And URM?
URM is purely geometric. It doesn't rely on a fluid medium. It relies on the curvature of proper time itself and phase-locking resonances. FOS is like studying the mechanics of ocean waves. URM is like studying the advanced mathematical harmony of a piano chord.
But they both agree on the core, fundamental tenet. Particles are not things. Waves, resonances, and field gradients are the true reality. They both want to replace a universe of things with a universe of processes.
Precisely.
Okay, let's step back. This all sounds incredibly compelling. If these alternative models, especially URM, can calculate the exact mass of an electron using pure geometry, if they can naturally explain dark matter without inventing invisible ghost particles, and if they reduce 80 convoluted fields down to a single principle of resonance, why aren't they taught in every university? Why is mainstream physics pushing back so hard?
Because the standard model, despite all of its complexity, its epicycles, and its 80 fields, is unequivocally the most rigorously tested and mathematically predictive theory in the history of human civilization.
It works.
It works incredibly well. To overthrow it, a new theory cannot just be logically simpler or mechanically intuitive. It must mathematically replicate the standard model's extreme, mind-boggling predictive precision across millions of high-energy particle collisions.
And this is where URM and FOS hit a massive brick wall. Let's talk about the obstacles they face in high-energy physics, because we can't just champion the alternatives without impartially looking at where they fail. The first major hurdle is the S-matrix and the strong force. Before we debate it, explain what an S-matrix is.
Think of an S-matrix as the ultimate accounting spreadsheet for particle physics. It stands for scattering matrix. When you smash two particles together, you don't always get the same result. It's probabilistic.
Okay.
The S-matrix is the complex mathematical framework that allows you to calculate the exact probability of every possible outcome of that collision. If input A and input B hit at this speed, there is a 40% chance of output C and a 60% chance of output D.
And the standard model fills out that spreadsheet perfectly.
Flawlessly. Specifically, regarding the strong nuclear force, the force the standard model says holds quarks together, the math is described by a highly complex symmetry called SU3.
And SU3 includes incredibly weird, nonlinear phenomena, right? Like asymptotic freedom.
Yes, Asymptotic freedom is fascinating. In the Standard Model, quarks act like they're connected by a rubber band. When quarks are very close together inside the proton, the rubber band is slack and they act completely free.
But if you try to pull them apart,
The rubber band stretches, and the force pulling them back together gets exponentially stronger the further away they get. That's called color confinement, and it's why we never see isolated quarks. The SU3 math predicts this rubber band behavior perfectly.
and how does URM handle that?
Yeah.
URM relies on simple linear harmonic resonance. Just beautiful, simple time loops. How does it replicate the rubber band?
URM claims that the SU3 and rubber band effect isn't a new force. It claims the math emerges naturally from the three orthogonal axes of the proton's eta-cube geometry. The three axes interact non-linearly.
But claiming it and proving it are two different things.
Exactly. URM has not yet produced the rigorous S-matrix scattering calculations to prove it. Mainstream physicists look at URM and say, your geometry is pretty, but until you can fill out the scattering spreadsheet as accurately as SU3, your theory is useless in a collider.
And the pushback gets even more specific when we talk about the electroweak hurdle, specifically the W and Z bosons. Come on, we have literally built massive multi-billion-dollar machines like the Large Electron-Positron Collider, and we have seen the W and Z bosons. We've measured their masses exactly 80.3 GeV for the W and 91.1 GeV for the Z. How can URM or Theory A just ignore particles we have photographed?
Well, URM doesn't ignore them, but it radically reinterprets them. URM dismisses them as being actual independent particles.
How can a measured mass of 80.3 GeV not be a particle?
URM interprets the W and Z bosons as mere symbolic collapses or curvature stress limits of the field.
Symbolic collapses.
Let's use an analogy. Imagine a concrete bridge collapsing under too much weight. When the bridge snaps, it releases a massive distinct acoustic boom, a sound wave of a very specific energy.
Okay, I'm with you.
In the Standard Model, when a particle undergoes radioactive beta decay, it emits a physical W boson, which then decays into other things. URM says, no, a physical particle isn't being emitted. What's happening is that the original particle reached a geometric failure point in its phase resonance. Its loop snapped. And that snapping creates a massive, transient curvature spike, like the acoustic boom of the bridge collapsing.
So the W and Z bosons are just the geometric boom of a resonance breaking.
Yes, URM calls them resonance failure states, not fundamental building blocks. But mainstream physicists absolutely reject this. The W and Z bosons leave massive, highly localized, predictable resonant peaks in collider data. Their interactions are perfectly described by the electroweak theory.
So dismissing them as symbolic booms isn't enough when the Standard Model predicts their exact masses and decay rates flawlessly.
Right. URM hasn't provided an alternative derivation for why the boom happens exactly at 80.3 GeV.
But the ultimate battleground, the absolute pinnacle of this precision war, is the muon G2 anomaly. Why is the muon such a massive deal in physics right now?
The anomalous magnetic moment of the muon, which is basically a measure of how much this heavy electron-like particle wobbles when you put it in a magnetic field, is one of the most precisely measured values in all of human science.
How precise are we talking?
Parts per billion. The Standard Model can predict exactly how much the muon will wobble to incredibly extreme decimal places. It does this using quantum electrodynamics, or QED, which requires calculating the effect of virtual particles.
Wait, virtual particles. Explain that.
In QFT, empty space isn't empty. It's a boiling sea of temporary particles popping in and out of existence for fractions of a nanosecond. When the muon travels through space, it is surrounded by a cloud of these virtual particles, and they slightly shield its magnetic charge, altering its wobble.
And the Standard Model calculates all of that.
Yes, it mathematically tallies up millions of these virtual interactions to predict the final wobble.
It's an insanely complex calculation. And what does URM say? Because URM doesn't believe in virtual particles popping out of nowhere.
Exactly. URM claims that the anomaly, the wobble, isn't caused by a cloud of ghostly virtual particles. It claims it's caused by an internal curvature asymmetry.
Meaning what?
Remember that URM uses the golden spiral to trap time. Because the muon is much heavier and smaller than an electron, it curves time much more deeply. URM argues that at that extreme depth of curvature, the geometry of space itself exerts a tiny physical torsion or twisting force on the particle's internal loop.
So it's wobbling because the tight geometric knot is experiencing structural stress.
Yes, and URM gives a rough geometric calculation for this torsion that perfectly matches the 4.2 sigma deviation we currently see in Fermilab experiments.
Wait, it matches the anomaly.
It matches the macro level deviation, yes. However, and this is a massive however, URM has not yet produced a complete ab initio calculation from first principles that matches the extreme parts per billion precision of the Standard Model's QED calculations.
It's so important that we remain totally impartial here. The Standard Model absolutely wins on extreme, battle-tested predictive precision. It has the exhaustive accounting math to back up every single decimal point. But these resonance theories, URM, Theory A, FOS, they win on mechanical, logical simplicity.
They do.
They provide a physical reason for why things happen, like geometric torsion or pressure equalizing, rather than just relying on abstract mathematical bookkeeping and virtual ghost particles.
That is the core tension defining theoretical physics today. Do we prefer a highly complex mathematical model that predicts experimental outcomes perfectly but lacks a clear physical underlying mechanism? Or do we want a simple, intuitive mechanical model that makes logical sense but hasn't yet achieved the necessary mathematical rigor to predict chaotic high-energy scattering?
To settle a theoretical stalemate like this, math isn't enough. You need physical proof. You need to test the untestable. How are scientists actively trying to prove these resonance theories today in modern labs? Because this isn't just philosophers sitting in armchairs. There are physical experiments proposed and underway right now.
Yes, the search for empirical evidence is very real. The first major test is aimed at proving Theory A. It's called the A-field interferometer.
I love the mechanics of this one. It's like LIGO, right?
Exactly. LIGO is the massive observatory that proved Einstein's gravitational waves exist by firing lasers down multi-kilometer tunnels and measuring microscopic changes in the lasers phase. The A-field interferometer proposes a similar optical test, but aimed at a fusion reactor.
Explain how a fusion reactor proves Theory A.
Remember that Theory A predicts that light slows down in a dense A field. And a dense A field is created by high mass energy density. So the proposal is to fire a highly precise, stabilized laser directly through the super-dense, high-energy plasma of a tokamak fusion reactor.
Because the plasma is so dense, Theory A says the field inside the reactor is thicker.
Yes. If the theory is right, the laser light traveling through the plasma will experience a microscopic time delay, a measurable delta T, compared to a reference laser traveling through normal air. When the two lasers recombine at the detector, that time delay will cause a visible phase shift in the light waves.
And if they observe that?
If observed, it would definitively prove that local field density directly slows the speed of light, entirely independent of traditional gravitational mass.
If they pull that off and measure the shift, that would be a Nobel Prize on day one. It would rewrite cosmology. But there's a specific, brilliant test for URM, too, involving the National Institute of Standards and Technology, or NIST. It's called the 207-nanometer UV spike. How does a hot box prove that space folds?
This experiment is brilliant because it doesn't require a particle collider. It just requires extreme controlled heat. URM predicts that the base quantum of energy required to trigger curvature locking or alpha value is exactly 5.96 keV.
Right. The minimum energy to fold the origami.
Exactly. If you take a completely empty vacuum-sealed cavity and heat it to extreme temperatures around 15,000 Kelvin, you are flooding that space with pure thermal kinetic energy. URM predicts that at that precise temperature threshold, the random thermal photons will occasionally hit that exact 5.96 keV limit and trigger microscopic temporary curvature locking events.
They will accidentally tie themselves into little knots of mass for a fraction of a second.
Yes, and when those knots instantly unravel back into light, they will emit a very specific, sharp delta spike in the ultraviolet emission spectrum at exactly 207 nanometers.
Meaning, it does not matter what material the box is made of. If you get empty space hot enough, the geometry of the space itself will start spitting out a specific frequency of UV light just because of the geometry folding and unfolding.
Precisely. A material-independent emission line would be massive proof of geometric resonance.
But they are using traditional colliders too, aren't they? What is happening at the Bell II collider in Japan?
Bell II is uniquely positioned for this because it studies photon collisions. They literally smash high-energy beams of light together.
And what are they looking for?
If URM's spiral locking mechanism is real, when two photons interact with enough constructive harmonic energy, they should transiently fold into a resonance loop before decaying. This intermediate folding process consumes energy, it traps it. So this would show up in the detector as a highly specific leakage or missing energy pocket of exactly 5.96 keV.
So they smash two beams of light, measure the energy of the explosion, and if exactly 5.96 keV is missing from the ledger, it proves the light temporarily became mass.
Exactly. And the most exciting part is that the trigger algorithm for the Bell-Disick detector could theoretically be patched right now to look for this exact missing mass signature in the petabytes of existing collision data they already have.
And looking to the future, what about the Electron-Ion Collider, the EIC, that's being built in New York?
The EIC is going to conduct deep inelastic scattering experiments. Essentially, it will take ultra-high-resolution flash photographs of the internal structure of a proton.
So we will finally get to see if there are three quarks inside or just water balloon ripples.
Yes. If the standard model is right, the EIC will map a chaotic, messy sea of fluctuating quarks and gluons. But if URM is right, the proton is an eta-cubed triloop vortex, a highly structured geometric coil. This geometric coil structure predicts a specific percentage-level shift, or a flattening, in the proton's electromagnetic form factors at low momentum transfers.
It predicts a specific shadow shape.
Exactly, and the EIC will finally have the resolution precision to detect if that structural flattening exists.
It's amazing that we are building machines capable of looking at the literal shape as an echo in time. But perhaps the most modern, mind-bending tool being used in this quest isn't a collider or a laser at all, it's artificial intelligence. The source is mentioned in an initiative called FERMI-ASSI.
FERMI-ASSI, it stands for Fast Engine for Reinterpretation, a machine intelligence accelerator. It is not just a search algorithm, it is a collection of AI agents acting as theoretical physicists.
How does an AI act as a physicist?
It autonomously reads through thousands of pages of experimental collider data, looking at all the anomalies and weird data points that the standard model struggles to explain. It then uses an adversarial proposer-critic loop. One AI generates novel geometric wave-based hypotheses like URM to explain the anomaly.
And the critic.
The critic AI then checks that geometric model against a deterministic particle physics simulator to see if it holds up to the laws of thermodynamics and conservation of energy.
It's like having a supercomputer brainstorm entirely new ways to fold the origami of the universe, testing millions of geometric combinations in the time it takes a human to write one research paper.
Exactly. It is designed to speed up the testing of these non-standard models by exploring the vast landscape of theoretical permutations far faster than human theorists ever could. It highlights just how seriously some factions of the physics community are taking the need for alternative geometric models. They are dedicating massive computing power to finding the math.
So let's pull all of this immense complexity together. We've gone on a massive journey today in this deep dive. We started with Einstein's unfinished dream of a purely geometric universe, a world of solitons rather than separate billiard balls.
Right, the hyperfield.
We looked at Louis de Broglie's clock wave, which evolved into particle theory, the radical idea that mass is just a dense illusion of a single vibrating fluid, and gravity is simply the restoring gradient, the pressure pushing us down as the universe tries to equalize.
We explored the exacting mathematics of the unified resonance model, deriving the mass of the electron and proton geometrically from the base energy alpha and the golden spiral amplifier eta cubed.
And we contrasted this purely geometric musical approach with the literal mechanical fluid dynamics of the fabric of space model, where a proton is just a pulsating ripple in a drop of water.
We also impartially examined the brutal, necessary pushback from the mainstream standard model, the strict demands for S-matrix statistical precision, the undisputed reality of W and Z bosons and collider data, and the parts per billion hurdle of the muon G2 anomaly.
And finally, we looked at the incredible, tangible lab experiments happening right now, from UV spikes in hot boxes to AI particle physicists, all trying to prove that reality is just a resonance.
If we connect this back to you, the listener, navigating your everyday life, it is a profound perspective shift. If you look at your own hand right now, whether you subscribe to the 80 different fields of the standard model or the unified fluid of field A, the fundamental reality is the same. The solid world you interact with, the chair you are sitting on, the screen you're looking at is fundamentally an illusion.
It is empty space.
It is a symphony of interacting vibrations, frequencies, and geometry. You are navigating a world of structured, trapped energy, not solid objects. When you put your hand against a wall, it isn't solid matter hitting solid matter. It is just two vibrating wave structures repelling each other with electromagnetic force.
Which brings me to a final, slightly provocative thought to leave you with today. We've talked extensively about how energy and frequency can fold into a stable geometric resonance, trapping time and creating what we physically perceive as mass and solid matter. But what about information?
Information. You mean data.
Yeah, data. Thoughts. The sources we reviewed today briefly touch on something called active matter theory and information entropy. If physical matter is just a stable resonance, a highly organized geometric echo trapped in a field, what happens to the mass of a complex thought? Or the mass of a piece of digital information?
That is crossing into fascinating territory.
If these geometric resonance theories suggest that the organization of waves creates physical gravity and information entropy can literally govern physical motion, are we approaching a point where physics and information theory are literally the exact same science?
Wow.
Is the universe just a quantum computer rendering itself through geometric resonance? If a 1 is a peak and a 0 is a trough, are we just living inside the math? It's something to chew on.
It entirely redefines what it means to exist. It blurs the line between a physical object and a line of code.
It really does. It takes us right back to that medical x-ray machine from the beginning of the hour. We thought we were looking at a clean, jagged line of a broken bone. We thought we were looking at solid quarks and distinct fields. But instead, we're looking at a resonance. We're looking at a song played on the fabric of time itself.
And as a scientific species, we are just barely starting to learn how to read the sheet music.
Exactly. Thanks for taking the plunge with us today. Keep questioning the fundamentals.